Applications of chemistry in the production of pesticides and herbicides. Chemistry plays a crucial role in the production of pesticides, herbicides, and other agrochemicals that are essential for modern agriculture. These chemicals are used to protect crops from pests and weeds, increasing yields and ensuring food security for populations around the world. In this article, we will explore the applications of chemistry in the production of pesticides and herbicides, and the impact of these chemicals on agriculture and the environment. Pesticides are chemicals that are used to kill or control pests, including insects, rodents, and weeds. They are essential for modern agriculture, as they help to protect crops from damage and increase yields. However, the use of pesticides also carries risks, including the potential for environmental contamination and harm to human health. Chemistry plays a key role in the development and production of pesticides. Scientists use a variety of chemical reactions and processes to create pesticides that are effective against specific pests while minimizing their impact on the environment and human health. This involves synthesizing and testing new chemical compounds, as well as developing methods for their safe and effective use in agriculture. One of the most common types of pesticides is the insecticide. These chemicals are designed to kill or repel insects that can damage crops and reduce yields. Insecticides work by disrupting the nervous system of insects, causing paralysis or death. They are typically applied to crops using sprays, dusts, or baits. The development of insecticides has been a major focus of chemical research in recent years. Scientists have worked to create insecticides that are highly effective against pests while minimizing their impact on non-target organisms, such as bees and other beneficial insects. This has led to the development of a new generation of insecticides that are more targeted and less harmful to the environment. Herbicides are chemicals that are used to kill or control weeds. They are essential for modern agriculture, as they help to prevent weeds from competing with crops for resources such as water and nutrients. However, like pesticides, herbicides also carry risks, including the potential for environmental contamination and harm to human health. Chemistry plays a crucial role in the development and production of herbicides. Scientists use a variety of chemical reactions and processes to create herbicides that are effective against specific types of weeds while minimizing their impact on the environment and human health. This involves synthesizing and testing new chemical compounds, as well as developing methods for their safe and effective use in agriculture. One of the most common types of herbicides is the glyphosate-based herbicide. Glyphosate is a broad-spectrum herbicide that is highly effective against a wide range of weeds. It works by inhibiting an enzyme that is essential for plant growth, causing the plant to wither and die. Glyphosate is typically applied to crops using sprays or as a pre-emergent treatment. The use of glyphosate has come under scrutiny in recent years, due to concerns about its impact on the environment and human health. Some studies have suggested that glyphosate may be carcinogenic, while others have raised concerns about its potential impact on non-target organisms, such as birds and mammals. Despite these concerns, glyphosate remains one of the most widely used herbicides in the world, due to its effectiveness and low cost. However, scientists continue to explore new chemical compounds and methods for controlling weeds that are less harmful to the environment and human health. In addition to their applications in agriculture, Pesticides and herbicides also have a range of industrial and commercial uses. For example, they are used in the production of wood preservatives, textiles, and other materials to prevent damage from insects and pests. Pesticides and herbicides are also used in public health programs to control the spread of diseases such as malaria, dengue fever, and Zika virus. These chemicals are used to kill or repel disease-carrying insects such as mosquitoes and ticks, reducing the risk of transmission to humans. However, the use of pesticides and herbicides also carries significant risks, both to human health and the environment. Exposure to these chemicals has been linked to a range of health problems, including cancer, respiratory illnesses, and neurological disorders. In addition, pesticides and herbicides can have harmful effects on non-target organisms, including pollinators such as bees and other beneficial insects. This can disrupt ecosystems and have ripple effects throughout the food chain. To address these concerns, scientists and policymakers have worked to develop and implement more sustainable and environmentally friendly methods for controlling pests and weeds. This includes the use of integrated pest management (IPM) practices, which combine a range of approaches, such as biological control, crop rotation, and the use of resistant crop varieties, to reduce the need for pesticides and herbicides. Another approach is the use of precision agriculture technologies, such as drones and sensors, to more precisely target the application of pesticides and herbicides. This can reduce the amount of chemicals used and minimize their impact on the environment and non-target organisms. In conclusion, while pesticides and herbicides are essential tools for modern agriculture and have a range of industrial and public health applications, their use also carries significant risks to human health and the environment. It is critical that scientists and policymakers continue to explore more sustainable and environmentally friendly methods for controlling pests and weeds, and work to minimize the impact of these chemicals on ecosystems and non-target organisms. One approach that has gained increasing attention in recent years is the use of natural products and biopesticides for pest and weed control. Biopesticides are derived from natural sources, such as plants, fungi, and bacteria, and are designed to control pests and weeds in a sustainable and environmentally friendly way. Biopesticides have several advantages over traditional chemical pesticides and herbicides. They are generally less toxic to non-target organisms, such as bees and other beneficial insects, and have fewer negative impacts on the environment. They also tend to have shorter residual effects, meaning that they break down more quickly in the environment, reducing the risk of contamination. One example of a biopesticide is neem oil, which is derived from the seeds of the neem tree. Neem oil is effective against a wide range of pests, including insects and mites, and is also used as a natural fungicide. It is considered safe for use on food crops, and has no known negative impacts on human health or the environment. Another example of a biopesticide is Bacillus thuringiensis, BT, a bacteria that produces a toxin that is effective against a range of insect pests. BT has been used in agriculture for over 50 years and is considered safe for use on food crops. It is also used in public health programs to control mosquito populations. Biopesticides are also being developed for use in organic agriculture, where chemical pesticides and herbicides are prohibited. Basic acids and bases in chemistry. Chemistry is a fundamental science that seeks to explain the behavior of matter at the molecular level. One of the key concepts in chemistry is the study of acids and bases, which are essential for many chemical reactions and play important roles in our daily lives. In this article, we will explore the basic types of acids and bases in chemistry, their properties, and their applications in various fields. Acids are substances that can donate hydrogen ions, H+, to a solution, while bases are substances that can accept hydrogen ions. The concept of acidity and basicity is measured using the pH scale, which ranges from 0 to 14, with 7 being neutral. A solution with a pH less than 7 is considered acidic, while a solution with a pH greater than 7 is considered basic. One of the most common types of acids is the mineral acid. Mineral acids are inorganic acids that are typically derived from minerals, such as sulfuric acid, H2SO4, and hydrochloric acid, HCl. Mineral acids are strong acids, meaning that they completely dissociate in water to produce hydrogen ions. They are commonly used in industry for a variety of purposes, including the production of fertilizers, detergents, and other chemicals. Organic acids are another type of acid that are derived from organic compounds, such as carboxylic acids. Organic acids are typically weaker than mineral acids, meaning that they do not completely dissociate in water. Examples of organic acids include acetic acid, chiku, which is found in vinegar, and citric acid, C6H8O7, which is found in citrus fruits. Bases can also be classified into two main types: strong bases and weak bases. Strong bases are substances that can completely dissociate in water to produce hydroxide ions, O, such as sodium hydroxide, NO, and potassium hydroxide, CO. Weak bases, on the other hand, only partially dissociate in water to produce hydroxide ions. One of the most common types of bases is the alkaline base. Alkaline bases are typically derived from minerals, such as calcium hydroxide, CaO2, and magnesium hydroxide, MgO2. Alkaline bases are commonly used in industry for a variety of purposes, including water treatment and the production of paper and textiles. Ammonia, NH3, is another common base that is used in a variety of applications. Ammonia is a weak base that has a pungent odor and is commonly used in household cleaning products, as well as in the production of fertilizers and other chemicals. Acids and bases have a wide range of applications in various fields, including medicine, agriculture, and industry. For example, acid-base reactions are essential for the digestion of food in the stomach. In agriculture, acids and bases are used to adjust the pH of soil, which can affect the growth and yield of crops. In industry, acids and bases are used in the production of a wide range of products, including plastics, detergents, and pharmaceuticals. One of the most important applications of acids and bases is in the field of chemistry itself. Acid-base reactions are essential for many chemical reactions, including the synthesis of new compounds and the analysis of chemical samples. Acid-base titrations, for example, are commonly used to determine the concentration of acids and bases in a solution. In conclusion, acids and bases are essential concepts in chemistry that play important roles in many applications. Acids can be classified into mineral acids and organic acids, while bases can be classified into strong bases and weak bases. Alkaline bases and ammonia are common bases used in industry and household applications. Acids and bases have a wide range of applications in various fields, including medicine, agriculture, and industry, and are essential for many chemical reactions in the field of chemistry. Acids and bases also have important applications in environmental chemistry. One of the most significant environmental issues related to acids and bases is acid rain. Acid rain is caused by the release of sulfur dioxide and nitrogen oxides into the atmosphere, which react with water vapor to form sulfuric acid and nitric acid. Acid rain can have a range of negative impacts on the environment, including the acidification of lakes and rivers, damage to forests and crops, and the corrosion of buildings and infrastructure. Acid rain can have a range of negative impacts on the environment, including the acidification of lakes and rivers, damage to forests and crops, and the corrosion of buildings and infrastructure. To prevent the negative impacts of acid rain, various strategies have been developed, including the use of scrubbers to remove sulfur dioxide and nitrogen oxides from power plant emissions, and the use of alternative energy sources, such as wind and solar power. Additionally, alkaline materials, such as limestone and lime, can be added to lakes and rivers to neutralize acid and restore the pH balance. Bases also play an important role in neutralizing acidic spills and waste. For example, sodium hydroxide, NO, is commonly used to neutralize acidic spills in laboratories and industrial settings. Neutralization reactions between acids and bases result in the formation of water and a salt, which can be safely disposed of. Acids and bases also have important applications in the field of medicine. The pH of the human body is tightly regulated to maintain homeostasis and prevent disease. Blood, for example, has a pH range of 7.35 to 7.45, which is slightly basic. Acid-base imbalances in the body can lead to a range of health problems, such as acidosis and alkalosis. Doctors and medical professionals use acid-base analysis to diagnose and monitor a range of medical conditions, such as respiratory and metabolic acidosis, which can be caused by conditions such as diabetes and kidney disease. Treatment for acid-base imbalances typically involves the use of intravenous fluids and medications to restore the pH balance. In addition to their importance in medicine, acids and bases also have applications in the food industry. Acids are commonly used as preservatives and flavor enhancers, while bases are used in the production of baked goods and other food products. For example, baking soda, sodium bicarbonate, NaCO3, is a common base used in baking to help dough rise. In conclusion, acids and bases are essential concepts in chemistry with important applications in a range of fields, including environmental science, medicine, and the food industry. In conclusion, acids and bases are essential concepts in chemistry with important applications in a range of fields, including environmental science, medicine, and the food industry. Acid-base reactions are essential for many chemical processes and are used to diagnose and monitor medical conditions. Acids and bases can also have negative impacts on the environment, such as acid rain, and must be carefully managed and neutralized to prevent harm. Applications of chemistry in electronics manufacturing technology. Chemistry plays a crucial role in the production of electronic devices, such as smartphones, computers, and televisions. Electronic devices rely on the properties of semiconductors, which are materials that have electrical conductivity between that of conductors and insulators. In this article, we will explore the applications of chemistry in the production of electronic devices, including the development of new materials and manufacturing techniques. One of the most important applications of chemistry in the production of electronic devices is the development of new materials for use in semiconductors. One example of a new material is graphene, which is a two-dimensional material made of carbon atoms arranged in a hexagonal lattice. Graphene has unique electrical and mechanical properties, such as high electrical conductivity and flexibility, which make it an ideal material for use in electronic devices. Another example of a new material is perovskites, which are a class of materials that have recently received a lot of attention in the field of photovoltaics. Perovskites have high absorption coefficients and can be easily processed into thin films, making them an attractive alternative to traditional silicon solar cells. Chemistry also plays a crucial role in the manufacturing of electronic devices. One important manufacturing technique is chemical vapor deposition, CVD, which is used to deposit thin films of materials onto a substrate. CVD involves the chemical reaction of a precursor gas with a heated substrate, resulting in the deposition of a solid film. Another important manufacturing technique is lithography, which is used to pattern the surface of a substrate with microscopic features. Lithography involves the use of a mask to selectively expose a substrate to light, which causes a chemical reaction that creates the desired pattern on the surface of the substrate. Chemistry is also used in the development of new manufacturing techniques, such as roll-to-roll processing, which is a high-throughput manufacturing technique that involves the continuous processing of a flexible substrate. Roll-to-roll processing is used in the production of flexible electronic devices, such as flexible displays and sensors. In addition to the development of new materials and manufacturing techniques, chemistry also plays a crucial role in the development of new electronic devices. One example of a new electronic device is the organic light-emitting diode, OLD, which uses organic materials to emit light when an electric current is applied. OLEDs have several advantages over traditional light-emitting diodes, LEDs, including improved color reproduction and higher energy efficiency. Another example of a new electronic device is the field effect transistor, FET, which is a type of transistor that uses an electric field to control the flow of electrons. FETs have several advantages over traditional bipolar junction transistors, BJTs, including lower power consumption and higher speed. In addition to the development of new materials and devices, chemistry also plays an important role in the recycling and disposal of electronic devices. Electronic devices contain a range of materials, including metals, plastics, and toxic substances, such as lead and mercury. Chemistry is used to develop methods for the safe and efficient disposal of electronic devices, such as the recovery of metals and the treatment of hazardous waste. In addition to the applications of chemistry in the production of electronic devices, there are also many applications in the field of electronics packaging. Electronics packaging involves the design and manufacturing of protective enclosures for electronic components and devices. Chemistry plays an important role in the development of new materials for electronics packaging, such as polymers and adhesives. Polymers are used to create protective enclosures that are lightweight, durable, and resistant to environmental factors, such as moisture and temperature changes. Adhesives are used to bond electronic components to substrates, and to join different components together. One important application of chemistry in electronics packaging is the development of thermal interface materials, TIMs. TIMs are materials that are used to improve the thermal conductivity between electronic components and heat sinks. TIMs can improve the reliability and performance of electronic devices by reducing the risk of overheating and thermal damage. Another important application of chemistry in electronics packaging is the development of coatings and films for protection against environmental factors, such as moisture and corrosion. Coatings and films can be used to protect electronic components from exposure to moisture, which can cause corrosion and damage to the components. Chemistry also plays an important role in the development of new manufacturing techniques for electronics packaging. One example of a new manufacturing technique is additive manufacturing, which is also known as 3D printing. Additive manufacturing allows for the production of complex geometries and customized designs, which can improve the functionality and performance of electronics packaging. In addition to the development of new materials and manufacturing techniques, chemistry is also used in the testing and characterization of electronic components and devices. Chemistry is used to analyze the composition and properties of materials, such as polymers and adhesives, to ensure that they meet the required specifications for electronics packaging. Chemistry also plays an important role in the analysis of electronic waste, which is an increasingly important issue in the electronics industry. Electronic waste contains a range of valuable and toxic materials, such as gold, copper, and lead. Chemistry is used to develop methods for the safe and efficient recovery of these materials, which can reduce the environmental impact of electronic waste. In conclusion, chemistry plays a vital role in the production and protection of electronic devices through electronics packaging. The development of new materials, manufacturing techniques, and testing methods are all critical to the design and production of high-quality electronic devices. Furthermore, chemistry is also essential in the analysis of electronic waste, which is becoming an increasingly important issue in the electronics industry. Continued research and development in the field of chemistry will be key in driving innovation and sustainability in the electronics industry. Chemistry also has important applications in the field of electronic materials characterization. Electronic materials characterization involves the analysis of the physical and chemical properties of electronic materials, such as semiconductors and dielectrics. One important application of chemistry in electronic materials characterization is the use of spectroscopic techniques. Spectroscopy is the study of the interaction between electromagnetic radiation and matter. Spectroscopic techniques, such as infrared spectroscopy and Raman spectroscopy, can be used to analyze the chemical composition and molecular structure of electronic materials. Spectroscopic techniques, such as infrared spectroscopy and Raman spectroscopy, can be used to analyze the chemical composition and molecular structure of electronic materials. Another important application of chemistry in electronic materials characterization is the use of microscopy techniques. Microscopy allows for the visualization and analysis of electronic materials at the microscopic and nanoscopic scales. Scanning electron microscopy and transmission electron microscopy are two commonly used techniques for electronic materials characterization. Chemistry also plays an important role in the development of new electronic materials. Electronic materials with unique properties, such as high electrical conductivity or high dielectric constant, are essential for the development of new electronic devices. Electronic materials with unique properties, such as high electrical conductivity or high dielectric constant. Applications of chemistry in the manufacture of cosmetics and makeup agents. Chemistry plays a crucial role in the development and production of cosmetics and beauty products. Cosmetics and beauty products rely on the properties of a wide range of chemicals, including polymers, emulsifiers, surfactants, and preservatives. In this article, we will explore the applications of chemistry in the production of cosmetics and beauty products, including the development of new ingredients and formulations. One of the most important applications of chemistry in the production of cosmetics and beauty products is the development of new ingredients. New ingredients are essential for the development of innovative and effective products that meet the needs and preferences of consumers. One example of a new ingredient is hyaluronic acid, which is a naturally occurring polysaccharide that is used in moisturizers and anti-aging products. Hyaluronic acid has the ability to hold up to 1,000 times its weight in water, making it an ideal ingredient for hydrating and plumping the skin. Another example of a new ingredient is vitamin C, which is a powerful antioxidant that is used in a variety of skincare products. Vitamin C has the ability to brighten the skin, reduce the appearance of fine lines and wrinkles, and promote collagen production. Chemistry also plays an important role in the formulation of cosmetics and beauty products. Formulation involves the creation of a specific combination of ingredients that provide a desired texture, color, and performance. Chemistry is used to determine the optimal combination of ingredients and to ensure that the product is stable and safe for use. One important aspect of formulation is the use of emulsifiers and surfactants. Emulsifiers and surfactants are used to create stable emulsions, such as lotions and creams, by allowing oil-based and water-based ingredients to mix together. Emulsifiers and surfactants are also used to create foaming and cleansing products, such as shampoos and body washes. Chemistry is also important in the development of color cosmetics, such as lipstick, eyeshadow, and blush. Color cosmetics rely on the use of pigments and dyes to provide a desired color. Chemistry is used to develop new pigments and dyes that are safe for use in cosmetics, and that provide a wide range of colors and effects. Another important aspect of cosmetics and beauty products is the use of preservatives. Preservatives are used to prevent the growth of bacteria and other microorganisms that can cause spoilage and contamination of the product. Chemistry is used to develop preservatives that are effective and safe for use in cosmetics and beauty products. In addition to the development of new ingredients and formulations, chemistry also plays an important role in the testing and safety evaluation of cosmetics and beauty products. Chemistry is used to analyze the composition and properties of ingredients and finished products to ensure that they meet the required specifications and safety standards. Chemistry is also used in the development of alternative testing methods, such as in vitro and computational models, that can reduce the need for animal testing in the safety evaluation of cosmetics and beauty products. In conclusion, chemistry plays a vital role in the development and production of cosmetics and beauty products. The development of new ingredients and formulations, as well as the testing and safety evaluation of these products, is essential for ensuring that they are effective, safe, and meet the needs and preferences of consumers. Continued research and development in the field of chemistry will be key in driving innovation and sustainability in the cosmetics and beauty industry. Chemistry also has important applications in the field of fragrance and flavor chemistry. Fragrances and flavors are complex mixtures of chemicals that are used in a wide range of products, including perfumes, colognes, air fresheners, and food and beverage products. One important application of chemistry in fragrance and flavor chemistry is the development of new ingredients. New ingredients are essential for the development of innovative and unique fragrances and flavors. Chemistry is used to synthesize new aroma and flavor compounds that have desirable qualities, such as long-lasting scent or intense flavor. Another important application of chemistry in fragrance and flavor chemistry is the analysis and identification of aroma and flavor compounds. Chemistry is used to identify the chemical composition of fragrances and flavors, allowing for the creation of accurate and consistent formulations. Analytical techniques, such as gas chromatography and mass spectrometry, are commonly used in fragrance and flavor analysis. Chemistry also plays an important role in the production of natural fragrances and flavors. Natural fragrances and flavors are derived from plant and animal sources and are becoming increasingly popular among consumers. Chemistry is used to extract and isolate fragrance and flavor compounds from natural sources, as well as to synthesize natural compounds in the laboratory. One important example of a natural fragrance is jasmine. Jasmine fragrance is obtained from the flowers of the jasmine plant and is used in a wide range of perfumes and beauty products. Chemistry is used to extract and isolate the fragrance compounds from the jasmine flowers, as well as to synthesize the compounds in the laboratory. Another example of a natural flavor is vanilla. Vanilla flavor is obtained from the pods of the vanilla orchid and is used in a wide range of food and beverage products. Chemistry is used to extract and isolate the flavor compounds from the vanilla pods, as well as to synthesize the compounds in the laboratory. In addition to the development and production of fragrances and flavors, chemistry also plays an important role in the testing and safety evaluation of these products. Chemistry is used to analyze the composition and properties of fragrance and flavor compounds, as well as finished products, to ensure that they meet the required specifications and safety standards. Chemistry is also used in the development of alternative testing methods, such as in vitro and computational models, that can reduce the need for animal testing in the safety evaluation of fragrance and flavor products. In conclusion, chemistry plays a vital role in the development and production of fragrances and flavors. The development of new ingredients, as well as the analysis and identification of aroma and flavor compounds, is essential for creating innovative and unique fragrances and flavors. Chemistry is also important in the production of natural fragrances and flavors and in the testing and safety evaluation of fragrance and flavor products. Continued research and development in the field of chemistry will be key in driving innovation and sustainability in the fragrance and flavor industry. Chemistry plays a crucial role in the development and production of hair care products. Hair care products include shampoos, conditioners, styling products, and hair treatments. These products rely on the properties of a wide range of chemicals, including surfactants, polymers, silicones, and natural extracts. In this article, we will explore the applications of chemistry in the production of hair care products, including the development of new ingredients and formulations. Applications of chemistry in the production of anti-corrosion and weather-resistant substances. Chemistry plays an important role in the development and production of corrosion and weather-resistant materials. Corrosion and weather-resistant materials are essential for a wide range of applications, including construction, transportation, and electronics. In this article, we will explore the applications of chemistry in the production of corrosion and weather-resistant materials, including the development of new materials and coatings. One of the most important applications of chemistry in the production of corrosion and weather-resistant materials is the development of new materials. New materials are essential for the development of innovative and effective products that meet the needs and preferences of consumers. One example of a new material is graphene, which is a single layer of carbon atoms that is highly conductive and has excellent mechanical properties. Graphene is used in a wide range of applications, including as a coating for metals to prevent corrosion. Another example of a new material is nanocellulose, which is a material made from plant fibers that is highly resistant to water and has excellent mechanical properties. Nanocellulose is used in a wide range of applications, including as a coating for paper and cardboard to make them water-resistant. Chemistry also plays an important role in the development of coatings for corrosion and weather resistance. Coatings are used to protect surfaces from corrosion and weathering, as well as to provide a desired appearance and texture. Chemistry is used to determine the optimal combination of ingredients and to ensure that the coating is stable and safe for use. One important aspect of coating development is the use of polymers. Polymers are used to create coatings that are flexible and resistant to cracking and peeling. Chemistry is used to design and synthesize new polymers that have the desired properties for use in coatings. In addition to the development of new materials and coatings, chemistry also plays an important role in the testing and evaluation of corrosion and weather-resistant materials. Chemistry is used to analyze the composition and properties of materials and coatings to ensure that they meet the required specifications and safety standards. Chemistry is also used in the development of alternative testing methods, such as electrochemical testing and accelerated weathering testing, that can provide accurate and reliable results in a shorter amount of time. Another important application of chemistry in the production of corrosion and weather-resistant materials is the use of corrosion inhibitors. Corrosion inhibitors are chemicals that are added to materials and coatings to prevent corrosion. Chemistry is used to develop new corrosion inhibitors that are effective and safe for use in a wide range of applications. One example of a corrosion inhibitor is zinc phosphate, which is commonly used in coatings for metal surfaces. Zinc phosphate reacts with a metal surface to form a protective layer that prevents corrosion. Another example of a corrosion inhibitor is organic inhibitors, which are chemicals that are derived from natural sources, such as plants and animals. Organic inhibitors are becoming increasingly popular due to their effectiveness and low toxicity. In addition to corrosion resistance, weather resistance is also an important property for materials used in outdoor applications. Weathering can cause materials to weaken and degrade over time, leading to reduced performance and shorter lifespan. Chemistry is used to develop materials and coatings that are resistant to weathering, including UV radiation, moisture, and temperature changes. One example of a weather-resistant material is fluoropolymers, which are highly resistant to UV radiation and moisture. Fluoropolymers are used in a wide range of applications, including as coatings for outdoor furniture and as insulation for electrical wiring. Another example of a weather-resistant material is ceramic coatings, which are highly resistant to temperature changes and moisture. Ceramic coatings are used in a wide range of applications, including as coatings for metal surfaces and as insulation for electronic components. Chemistry plays a vital role in the development and production of corrosion and weather-resistant materials. The development of new materials and coatings, as well as the testing and evaluation of these products, is essential for ensuring that they are effective, safe, and meet the needs and preferences of consumers. Continued research and development in the field of chemistry will be key in driving innovation and sustainability in the production of corrosion and weather-resistant materials. Chemistry is an important field in the production of high-performance materials, including those that are resistant to corrosion and weather. High-performance materials are critical for a wide range of applications, including aerospace, automotive, and construction. In this article, we will explore the various applications of chemistry in the production of high-performance materials, including the development of new materials and the optimization of existing ones. One of the most important applications of chemistry in the production of high-performance materials is the development of new materials. New materials are essential for the development of innovative and effective products that meet the needs and preferences of consumers. One example of a new material is carbon fiber, which is a lightweight and strong material that is used in a wide range of applications, including in the aerospace industry. Another example of a new material is metal organic frameworks, MOFs, which are porous materials that have a wide range of potential applications, including as catalysts and for gas storage. Chemistry is used to design and synthesize new MOFs with specific properties that are tailored for various applications. Chemistry also plays an important role in the optimization of existing materials. Optimization involves improving the properties of existing materials to make them more effective and efficient for various applications. One important aspect of material optimization is the use of nanotechnology. Nanotechnology involves manipulating materials at the molecular level to improve their properties. For example, nanotechnology can be used to improve the strength and durability of materials, as well as to make them more resistant to corrosion and weathering. Chemistry is used to design and synthesize nanomaterials with specific properties that are tailored for various applications. In addition to the development of new materials and the optimization of existing ones, chemistry also plays an important role in the testing and evaluation of high-performance materials. Chemistry is used to analyze the composition and properties of materials to ensure that they meet the required specifications and safety standards. Chemistry is also used in the development of alternative testing methods, such as computational modeling and simulation, that can provide accurate and reliable results in a shorter amount of time. Another important application of chemistry in the production of high-performance materials is the use of coatings. Coatings are used to protect surfaces from corrosion and weathering, as well as to provide a desired appearance and texture. Chemistry is used to determine the optimal combination of ingredients and to ensure that the coating is stable and safe for use. One important aspect of coating development is the use of nanotechnology. Plastics have become an integral part of our daily lives, from packaging materials to medical devices. While plastics are incredibly versatile and useful, they also have a negative impact on the environment. As a result, there is a growing interest in developing new, sustainable materials that can replace traditional plastics. In this article, we will explore the applications of chemistry in the production of plastics and how these innovations are helping to create more sustainable materials. Chemistry and the production of plastics. Plastics are typically made from polymers, which are long chains of repeating units. These polymers can be derived from natural sources, such as cellulose, or from synthetic sources, such as petrochemicals. The chemical processes used to create these polymers are complex and require a deep understanding of chemistry. One of the most common types of plastics is polyethylene, which is used in everything from plastic bags to food packaging. Polyethylene is made from ethylene, which is a gas that is derived from natural gas or petroleum. The chemical process of creating polyethylene involves polymerization, which is the process of joining together many small molecules, monomers, to form a large molecule, polymer. This process requires the use of catalysts, which are chemicals that help to speed up the reaction. Another common type of plastic is polystyrene, which is used in products such as foam cups and packing peanuts. Polystyrene is made from styrene, which is derived from petroleum. The process of creating polystyrene involves the use of a chemical called benzoyl peroxide, which is a polymerization initiator. This chemical helps to kickstart the polymerization process. Applications of chemistry in creating sustainable plastics. The production of traditional plastics has a negative impact on the environment, from the extraction of petrochemicals to the disposal of plastic waste. As a result, there is a growing interest in developing more sustainable materials that can replace traditional plastics. Chemistry is playing a key role in the development of these materials. One example of a sustainable plastic is polylactic acid, PLA, which is derived from renewable sources such as cornstarch or sugarcane. PLA is biodegradable and can be composted, which makes it a more sustainable alternative to traditional plastics. The process of creating PLA involves the use of chemistry to convert the starches into lactic acid, which can then be polymerized to create the PLA. Another example of a sustainable plastic is polyhydroxyalkanoate, PHA, which is made from bacteria that consume organic materials such as vegetable oil or cornstarch. PHA is biodegradable and can be composted, which makes it a more sustainable alternative to traditional plastics. The process of creating PFAS involves the use of chemistry to extract the PFAS from the bacteria and purify it for use as a plastic material. Chemistry is also being used to create biodegradable additives for traditional plastics, which can help to make these materials more sustainable. One example is oxo-biodegradable additives, which are added to traditional plastics to help them break down more quickly when exposed to sunlight or heat. The process of creating these additives involves the use of chemistry to create a catalyst that can accelerate the breakdown process. Conclusion: the production of plastics has a significant impact on the environment, from the extraction of petrochemicals to the disposal of plastic waste. Chemistry is playing a key role in the development of new, sustainable materials that can replace traditional plastics. From the creation of biodegradable plastics to the development of additives that can make traditional plastics more sustainable, chemistry is helping to create a more sustainable future. As the demand for sustainable materials continues to grow, chemistry will continue to play a crucial role in the development of these materials. The production of plastics is heavily reliant on chemistry. The most common plastics, such as polyethylene and polystyrene, are created through complex chemical processes that involve polymerization, which is the joining of many small molecules. Monomers to form a large molecule, polymer. Polyethylene, for example, is created from ethylene, a gas derived from natural gas or petroleum. The process of creating polyethylene involves the use of catalysts, which are chemicals that speed up the reaction. The catalysts help to initiate the polymerization process, allowing the monomers to join together and form the polymer. Polystyrene, another common plastic, is made from styrene, which is derived from petroleum. The process of creating polystyrene involves the use of a chemical called benzoyl peroxide, which is a polymerization initiator. This chemical helps to kickstart the polymerization process and form the polymer. Chemistry is also involved in the creation of additives for plastics, which can help to enhance their properties or make them more sustainable. For example, plasticizers are chemicals that are added to plastics to make them more flexible. UV stabilizers are chemicals that help to protect plastics from damage caused by exposure to sunlight. Flame retardants are chemicals that can help to reduce the flammability of plastics. The creation of sustainable plastics also relies heavily on chemistry. Plastics made from renewable sources, such as cornstarch or sugarcane, require chemical processes to convert the raw materials into usable polymers. Plastics made from renewable sources, such as cornstarch or sugarcane, require chemical processes to convert the raw materials into usable polymers. Polylactic acid, PLA, is an example of a sustainable plastic that is derived from cornstarch or sugarcane. The process of creating PLA involves the use of chemistry to convert the starches into lactic acid, which can then be polymerized to create the PLA. Polyhydroxyalkanoate, PHA, is another sustainable plastic that is created from bacteria that consume organic materials such as vegetable oil or cornstarch. The process of creating PHA involves the use of chemistry to extract the PHA from the bacteria and purify it for use as a plastic material. Other aspects of chemistry involved in the production of plastics include polymer chemistry. Polymer chemistry is the study of the structure, properties, and synthesis of polymers. Polymer chemists work to develop new polymers with specific properties, such as strength, flexibility, and durability, to meet the needs of various industries. Materials science. Materials science is the study of the properties, structure, and performance of materials. Materials scientists work to develop new materials with specific properties that can be used in various applications, including plastics. Analytical chemistry. Analytical chemistry is the study of the chemical composition and properties of substances. Ceramics are a class of materials that are widely used in various industries, including construction, aerospace, and electronics. Ceramic materials are typically made from inorganic compounds such as clay, feldspar, and silica, and can be produced using various chemical methods. In this article, we will explore the production and processing of ceramic materials from chemical compounds. Ceramic production methods. There are several methods for producing ceramic materials from chemical compounds, including powder synthesis. In this method, ceramic powders are synthesized from chemical precursors through a chemical reaction or a series of reactions. The resulting powder is then sintered to produce the final ceramic material. Sol-gel method. This method involves the production of ceramic materials from a sol, which is a liquid precursor containing metal alkoxides. The sol is then treated to produce a gel, which is then dried and sintered to produce the final ceramic material. Electroceramics. This method involves the production of ceramic materials from electrically conductive metal oxides. The metal oxides are mixed with a nonconductive material, such as a ceramic oxide, to produce a material that exhibits both electrical conductivity and ceramic properties. Bioceramics. Bioceramics are a type of ceramic material that is used in biomedical applications, such as bone implants. Bioceramics are produced using chemical methods, such as sol-gel or powder synthesis, and can be designed to exhibit specific properties, such as bioactivity and biocompatibility. Ceramic processing methods. Once ceramic materials have been produced, they must be processed to produce the final product. The following are some of the processing methods used in the production of ceramic materials. Shaping. Ceramic materials can be shaped into various forms, including tiles, plates, and tubes, using techniques such as extrusion, injection molding, and casting. Sintering. Sintering is a process in which ceramic materials are heated to a high temperature, causing the particles to fuse together and form a solid material. Glazing. Glazing is the process of applying a thin layer of glass to the surface of a ceramic material. Glazing can improve the appearance of the ceramic material, as well as its resistance to moisture and chemicals. Surface treatment. Ceramic materials can be treated with various chemicals to improve their properties, such as strength, toughness, and wear resistance. Benefits of ceramic materials. Ceramic materials offer several benefits over other types of materials, including high strength and hardness. Ceramic materials are known for their high strength and hardness, making them ideal for applications that require durability and resistance to wear. High resistance to heat and chemicals. Ceramic materials can withstand high temperatures and exposure to chemicals without degrading, making them ideal for use in harsh environments. Biocompatibility. Certain types of ceramic materials, such as bioceramics, are biocompatible, meaning they can be used in biomedical applications without causing an immune response. Electrical properties. Certain types of ceramic materials, such as electroceramics, exhibit electrical conductivity, making them useful for applications in electronics and telecommunications. In conclusion, ceramic materials are widely used in various industries due to their unique properties and versatility. Ceramic materials can be produced using various chemical methods, including powder synthesis and sol gel, and can be processed using techniques such as sintering and glazing. The benefits of ceramic materials, including their high strength, resistance to heat and chemicals, and electrical properties, make them an essential component of many products and applications. As the demand for ceramic materials continues to grow, the development of new and innovative production and processing methods will play a crucial role in meeting this demand. Bioceramics are a type of ceramic material that is used in biomedical applications, such as bone implants and dental prosthetics. Bioceramics are designed to exhibit specific properties that make them compatible with living tissue, such as bioactivity and biocompatibility. Bioceramics can be produced using various methods, including powder synthesis, sol gel, and electrospinning. The selection of the method depends on the specific properties required for the application. One of the most important properties of bioceramics is their bioactivity. Bioactive materials have the ability to bond with living tissue, promoting the growth of new bone tissue and allowing the implant to integrate with the surrounding tissue. Bioceramics can exhibit bioactivity through the release of ions, such as calcium and phosphate, which are essential for bone growth. Biocompatibility is another important property of bioceramics. Biocompatibility refers to the ability of the material to interact with living tissue without causing an immune response or adverse reactions. Bioceramics are designed to be biocompatible, allowing them to be used in biomedical applications without causing harm to the patient. Another important property of bioceramics is their mechanical properties. Bioceramics must have sufficient strength and toughness to withstand the stresses and strains of the body. The mechanical properties of bioceramics can be improved through the addition of reinforcing materials, such as carbon fibers or titanium. There are several types of bioceramics, including calcium phosphate ceramics. Calcium phosphate ceramics, such as hydroxyapatite, are commonly used in bone implants due to their bioactivity and biocompatibility. Bioactive glass ceramics. Bioactive glass ceramics are designed to exhibit both bioactivity and mechanical strength, making them useful in a range of biomedical applications. Zirconia ceramics. Zirconia ceramics are known for their high strength and toughness, making them ideal for use in dental implants. Bioceramics offer several benefits over other types of materials, including their ability to promote bone growth, their biocompatibility, and their mechanical properties. Bioceramics have revolutionized the field of biomedical engineering, allowing for the development of new and innovative solutions for a range of medical conditions. Sintering is a process used in the production of ceramic materials, which involves heating the material to a high temperature below its melting point to cause the particles to fuse together and form a solid material. The process is typically used to produce dense, high-strength ceramic materials with uniform properties. The sintering process involves several stages, including compaction. The ceramic material is first compacted into a desired shape, such as a disc or a rod, using techniques such as pressing or extrusion. The compacted material is known as a green body. Densification. The green body is then heated in a furnace to a temperature below its melting point, causing the particles to fuse together and form a solid material. The process is known as densification, and it typically involves several stages, including the removal of air and other gases from the material, the rearrangement of particles, and the formation of new chemical bonds between the particles. Grain growth. As the temperature of the material increases, the particles will begin to grow in size, a process known as grain growth.